Let's discuss about the alkyl halide and its preparations from alcohol. So basically, whenever we will represent an alkyl halide, I will always prefer to write capital R dash X. So it representing alkyl halide, and the group R representing the carbon chain. The carbon chain, whatever the carbon chain attached to the halide, that particular carbon chains will be termed it as R. So the box, the square bracket part representing the halide, this one will be representing the carbon chains where it will be more than 2, more than 3, or maybe any number of carbon compounds. So whatever the halide will be always the group 17. Group 17 means fluoride, chloride, bromide, and iodide. These are the preferential element of the group 17. And commonly, X will be either Cl or Br. The remaining two will be very rarely found in the atmosphere, and hence we will try to prepare only chloride and bromide alkyl halides. So alcohols means the compounds in which the carbon chains will be attached to an OH group. If it is attached to a carbon which is having 2 carbons nearby, then it will be considered as the 2 degree. And similarly, if it is having 3, then it will be 3 degree. 1, 2, 3. So these are the parts which has been already been discussed in the alcohol nomenclature. So if you have any problem regarding that, you may go to the alcohol chapters. Today I am discussing about 6 reactions. Number 1, alcohol react with HX in presence of a catalyst, that is ZnCl2. Reactions will lead to formation of a product of Rx, means alkyl halide, where the alcohol group, that is the OH, is replaced by the halide. So this one will be the Rx. So R group, whatever the R group it will be remains as it is. Similarly here, ROH will be replaced by the bromide Br, and this one will lead to form RBr. Similarly, in case of here, ROH in presence of phosphorus trihalide, P representing phosphorus, the product will be PX. Similarly, in the fourth one, alcohol, OH group, functional groups will be replaced by halide of phosphorus pentachloride or phosphorus pentahalide, leads to form PCl, PCl phosphoric acid, POCl3, and RCl. Similarly, in case of ROH, when I will apply the red phosphorus in presence of halide, commonly halide will be Br2 and I2. These times it will be used Br2 and I2. So leading to product Rx. Similarly, in ROH, SOCl will be replaced by replacing the OH group. So these are the basic 6 reactions we will study today. Number 1, number 2 will be number 1 will be with alkyl with halo acids. Number 2 will be sodium bromide or sodium iodide. Number 3 will be PCX3 or PCl3, like that. Number 4 will be with PCl5. Number 5 will be red phosphorus with halide, and number 6 will be SOCl2, which is commonly called as thionyl chloride. Alkyl halides are always best prepared from alcohols, whichever is easily accessible. Whichever is easily accessible, only that alcohol will be selected for the preparations of alkyl halide. Alkyl halide will be formed by replacing the OH group or the hydroxyl group. It will be replacing the hydroxyl group. Whatever the hydroxyl groups of the alcohol groups will be replaced by the halogens. Halogens means fluorine, chlorine, bromine, iodine. So these are the part of the reactions. As I have already mentioned in the initial part, that the reactions will be either haloacids, phosphorus trichloride, or phosphorus halides, which is including the PCl5, then PCl3, and red phosphorus and halide. So these are the part. And the thionyl chloride, that is the SOCl2. So you have to remember the names of the acids as well as the halides, as well as the what is the thionyl meanings of thionyl chloride, what is the symbol of thionyl chloride. You have to remember these 4 points. Okay. Here I am mentioning that the one reaction which is most useful for preparing alkyl halide from the alcohol is the last one, that is from the thionyl chloride. And now your question is why? And this is actually due to the all the reactions leads to 2 products. If you imagine for the first one also, here is the 2 product, here is the 2 product, 1, 2, 3, even 3 products are there. And on the third one also, here is 2 products are from it. Here also 2 products are from it. Here also they will have 1 product or more than 2 products will be obtained. But in the last one, they are the 3 products. But although that's 3 products, the rest of the 2 are highly volatile, or they will be escape out easily. They are the escaping gases, and hence I will prefer the last one commonly. So this is the accessible gases. So hence this is the one of the most important part, that alkyl halide preferentially always made from thionyl chloride. Why it is accessible? Why it is since the remaining 2, that is the SO2 and HCl, are easily removable or easily volatile and easily escape out. That is the easily escape out. SO2 and HCl will be escape out. That means it can be easily escape out as a gas. So left out will be RCl or the alkyl halide. Hence this one is the most important reactions, and commonly they will ask always, in your exam they will always ask the thionyl chloride reactions only. Here is the next target is to the phosphorus compound. So phosphorus, if I discuss about the phosphorus compound, so for 3 of the 4 phosphorus reactions is there. So these are the one is with PCl3 or PCl5, and another one is red phosphorus. These are the 3 reactions which is involving the phosphorus. So commonly phosphorus tribromide and triiodides are not accessible, and hence it has been prepared by the last one, that is the ROH, red phosphorus RX. Why this one is most suitable for preparing the bromide and iodide is that it is formed within the reactions itself. That's why this is called C2. This is commonly marked as C2, and C2 means the product, that reactant which is used for the catalyst will be formed in the reactions mixer. So phosphorus tribromide and triiodide is formed even in the reaction mixer, and hence this reactions is also called C2 reactions. Okay, so here it is ROH, red phosphorus, and halide is applied, so the product will be alkyl halide. And the very next reactions, I am showing that alcohols will be converted to alkyl halide by applying a haloacids. So this one is called haloacids. RX is commonly called as the haloacids. Now the question is that why it is the haloacids? If it is considered as the haloacids means HF, then HCl, then HBr, HI, etc. These are the called haloacids, means all the halide groups, if it has with an hydrogen 1, then this will be called as haloacids. When haloacid is treated with an alcohol, the alcoholic OH part will be replaced by the halide, and with it, one water molecules is also formed. So the reaction is always carried out either by passing dry hydrogen chloride. This is the dry hydrogen chloride gas, through the alcohol solutions, or by heating a solution of alcohol in concentrated acids, or I can pass it in with gas or HX, concentrate it and heat it. So these are the reactions. I can apply HX in gaseous medium, or I can apply HX, concentrated HX with heating. This particular reactions is also very useful for distinguishing 1 degree, 2 degree, 3 degree alcohol. Suppose you have 3 alcohol, that is 1 degree, either 1 degree, 2 degree, or 3 degree. And if I apply the HX or the halo acid on the alcohol, it will not only give the alkyl halide, which is implement for the preparations of alkyl halide, as well as we can useful it the reactions for the preparations for the distinguishing alcohol also. So to find out which alcohol we'll have, so let's find out. To find out that if it is appear on heating, if the alcohol react with HX only after heating, then this one should be 1 degree alcohol. If it is react after 5 minutes after adding of HX, it takes nearly 5 or 10 minutes, then this one should be 2 degree alcohol. And if it's immediately it react, then it will be 3 degree. Okay, so that means the reactions are X, the product is appear to be turbidity. Turbidity means haziness within the solutions, or it look bulky, or it will be look something like whitish, and it turns the turbidity. Okay, so 1 degree alcohol appears on heating, 2 degree after 5 minutes, and for 3 degree it will be appears immediately. So here, since 1 degree and 2 degree appears requires the presence of catalyst, and since it is the for 3 degree the order of reactivity is the higher in, so thus this one will be even at the room temperature the reactions can be takes place. Okay, so remaining 1 and 2 degree it cannot, so that's why you have to pass the halo acid gas through alcohol in presence of a catalyst, that is zinc chloride. But in case of 3 degree alcohol, you need to pass the gases through the alcohol. You simply put the alcohol in a concentrated HCl solutions, or whatever the halo acid you will have, and left it for at the room temperature, it will automatically turns to the product, that is the alkyl halide, which will be appeared as a turbidity or the precipitate type. So hence it appears immediately at the room temperature. So this is the way to distinguish out the alcohol. So this one is already included in your textbook in the alcohol chapter, so which is I have discussed it here itself. On the second part, on the last part, that is the bromide, if I use the HBr, so you have to take the HBr, if it is HBr, then you have to apply it in near about 48% or near about 50%, and prepared it with a constant boiling should be there. Constant boiling should be there, so that it will lead to the product. Okay, so preferentially, that's why we have preferentially use HCl or HBr. We will not use HF as well as HI. These are not being commonly used for preparing the alkyl halides. RF and RI is not useful for preparing alkyl halide. So since HF is a poisonous and HI is very much unstable, and hence these two will not be product obtained. So this is the part of the discussions which have included in your alcohol chapter. So kindly go through that. So in your alcohol chapter, there is a reactions. In the reactions of halo acids, they are mentioning it as the Lucas test. Tertiary alcohol turbidity appears immediately, while primary alcohols do not produce turbidity at room temperature, and for 2 degree it will be after, it will take nearly 5 minutes. So this test is also known as the Lucas test. This is also known as the Lucas test. And the last but not the least, we have discussed. Let's discuss about the a few questions that have been already been asked in your classes. So here it is with Ri may be obtained by preparing with taking the compound of alcohols with ROH plus NaI, NaBr, and NaF. NaPIF. So this one should not be there. It should be Ki, and this three, when I have prepared in phosphoric acid H3PO4, it will lead to form Ri. Okay, this is very explosive. So this is very unwanted reactions. So preparing alkyl, preparing Ri. So you just follow up that reactions too, which has not been discussed in your textbook also. So here one part is there that alcohols, whenever there is a alcohol, that is the cyclohexanol, and if it is having double bonds and OH, then this one should be aromatic. This one will be considered as ROH, but this one will not be considered as ROH. Rather, it will be considered as AROH, means this one will be aromatic. So here, if I use any reagents which I've discussed earlier, will lead to a product. Will lead to the product. But in case of benzene, they will not lead to any product. They will not lead any product. So hence, in case of phenol, they will not have any reactions. Will not be positive for any of the reactant that are being used except PCl5. PCl5, although in case of PCl5 in phenol, they will react to give the alcohol. Rest will not be formed. And the reasons behind this is that the aryl halides, carbon-oxygen bond in phenols has a partial double bond character. So if you observe, this one will be lifted to here, so then it will be, and resulting will be a double bond. There will be a double bond because of that. So hence this will be formed, and due to this double bond, they can't form easily the OH group, except PCl5. Okay. In case of PCl5, they will lead to the product. So let's discuss a few questions. So here it is the phenol. When I react with thionyl chloride, this one is thionyl chloride. So this one is aliphatic alcohol. This one is cyclic alcohol. This one I can represent as ROH, and product will be this one. This one will be the product. In place of which I will write Cl plus SO2 plus HCl. So this will be the product. SO2 is a volatile, HCl2 is a volatile, so product will be this one. But here, in case of the second one, there are the two parts of alcohol. One is this one, and one is in this one, and another one is with here. But in case of the first one, this is the part of the aliphatic chain. So this one can be replaceable, or OH group can be replaceable by the halide. But this particular OH cannot be replaceable, since this one is the aromatic alcohol. This one is a phenol. This one is a phenol, and this one is the alcohol. So hence product will be this one. So here the product will be this one. This OH will be retained, and this one will be CH2, and OH will be shifted to Cl. I request you all to write each and every organic compounds in respective structural formula, so that it will be comfortable for you as well as for the others too. Now, the same reactions is given as in terms of PCl5 and in terms of PCl3. So in terms of here, it is the PCl3. So product will be same. And here it is HCl. So product will be the same. So both the products can lead to the product, just like the earlier. So here also this one will be in place of OH, I will write Cl. It cannot be happen for the benzene, so no need to write that for the benzene, alcohol benzyl part. So here it is the part CH2. Here is the benzene. This OH will be retained. This one will be retained, and in place of Cl, in place of OH, this time I will write Cl. Okay, so this one is also similar to the earlier one. So here you are being asked to determine which one will react with SOCl2. This one is in the cyclic alcohols, and the part of this one is alcohol. And here also this one is alcohol, but the second portion is not the alcohol. This one is phenol. So here, and the first one, the product will be this one. So product will be this one. In place of OH, it will be Cl. And the second one, the product will be this one, benzene will be there. So here it is OH, OH will be remains as it is, since it is the aromatic alcohol. This one is aromatic, this one is aromatic, this one is aliphatic. So aliphatic only can be converted, aliphatic only can be converted, ROH can be converted, AROH cannot be converted. So product will be CH2Cl. At the very chapter ending exercise, there is an exercise in the number 6 is there. So what will be the product? So CH3, CH2, CH2 in place of OH. Due to the presence of SOCl2, I will write Cl plus SO2 plus HCl. So this is the answer for that particular questions. Remaining will be discussed on the later part of the series. And so I am just giving a few homeworks for you people, so that just go through it and send me in the earliest. So here it is CH2, CH3, CH2, 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 OH in presence of PCl3. What would be the product? And the second one, CH3, whole 3COH. HCl in presence of room temperature, only HCl in presence of heat. And on the third one, sorry, only HCl is given. Only HCl is given. And the third one, CH3 whole 2 CHOH in presence of SOCl2. So try to write down the name also. Try to write the name of the UPAC names also. And for the fourth, let's have this one, CH3, CHOH. So what would be the product? So this one will be PCl5. What would be the product? And on the fifth, so what would be the product for this one too, PCl5. So kindly complete it out and if you have any problems, don't forget to comment me out. So these are the very easy one. So try to find out. Next, in your chapter, in your chapter of the aldehyde and ketone, there is also a discussions of these reactions where the PCl5, PCl3, and SOCl2 undergo the reactions with carboxylic groups also, carboxylic also. So here it is the carboxylic group RC, double bonded O, bone OH. So here it is a hydroxyl group which will be replaced by PCl5 as well as PCl3 and with SOCl2 only. These two can take part. So here product will be RC, double bonded O's, in place of X, OH, this time it will be Cl. And remaining product will be same. So if it is PCl5, that PCl3 plus HCl, if it is with a PCl3, H3PO3, and if it is with SOCl2, SO2 and Cl2. That means this product will be remaining same with the earlier one, except the first one. So this one will be discussed in details in the later part, but presently you just write down it out for the convenience as a rough work. Okay, no need to take part in the main copy. Okay, this one should be write down as a rough work only. So hope you have gone through all through discussions of the alkyl halide today. If you have any query, so kindly don't forget to comment me back. So whatever problems you will have or related to reactions and salts. So if you have any problems or any query, don't forget to comment me out. So these are the starting of the reactions, so preparation. So this is the number 1 part. Okay, thank you all. Hope